Okay. So now we'll see. This is the another one more diagram. This is what whichever I shown here the previously diagram is here. The internal circuitry diagram of full adder using half adder block. Now what I will do, I will write the same program with some other way here. You see the full adder using two half adder here, right? So let me start the same thing even here also. So first the initially it will be this only. So this never changes. This will not change. This is common only. Full adder using common. So C in this is sum actually. S is there. So let me take as per this only. This diagram, whatever is given. Let me choose yes. Then it is C. Yes. Then this will be C. Then you see the wire, the first half adder will produce sum and carry. So here we given between the two half adder, it is S1, yes. Then the first half adder will produce the carry given to second half adder carry connected to the OR gate that will produce the output of carry actually. So here you see this will be your C1, that is one more C2. So what I will do, let me choose the same thing, C1 and C2. Just wire. See, whatever is given, the same thing I'm using here. Okay. Now let us go for the. Now what I'm doing earlier, we instantiated the gates here. You remember this XR. Okay, I need to say very important because you may think then this is the keywords. Actually, these are all keywords. This is not user defined. It is a keyword. See, these are the keywords actually. Here which is already inbuilt in the Verilog code. Actually, as soon as I pass this input parameters, it will execute. You can understand this is the gate. Now what I'm going to do, I'm not going to use the primitives here. This is with primitives. Now this is without primitives. So now what you'll do, instantiate half adder. Now first you see this is nothing but your the half adder 1. See here, let me say, yes. Yes, see, this one. This is half adder 1, HA1. I will name it as HA1. This is HA2. I will name it like this. Now let me write here, first HA, that is half adder HA1, this label name. Then you think you may have the doubt now. I written half adder. You are having the doubt as whether the system has inbuilt half adder, whether the system has inbuilt half adder or not. You are having the doubt like that. So now what you can do in the sense of underscore adder. So later I will tell what is this half adder HA1. Now you tell me here. Always try to write output comma input. So now which is the output and which is the input? Now you look into only this half adder. Don't see the other half adder. You see only this half adder. Now you tell me what is the output and input? The outputs of this half adder is S1, correct? S1, comma. Then what is one more is this one, right? C1. Okay. Next is inputs A, comma B. See, like this you have to write. See now what I did now? Here half adder. So this is half adder actually. HA1, HA2 I given. Still you are having a doubt where this half underscore adder I written whether it has inbuilt or not. It is not inbuilt. We need to write separate program of half adder. So that I will show there. Second you write here second half adder HAF underscore adder HA2. Now you'll think about the second half adder. What is the second half adder now? Output is sum is yes. You see this sum is yes. Okay. Next, what about the carry? Carry is nothing but C2. Okay. What about next? A, B, not A. You should not write as A. The A is nothing but what? S1 actually. The voice signal S1. So write as S1. Next, what about B? The B input signal is nothing but Cin actually. So write as Cin. Then end. So now what you will do? Instantiate the OR gate. Because only one gate. So now what you do? The single OR gate, it is a primitive actually. So OR, then R1 label. Then what is the output? Output is C. The inputs are what? C1 comma C2. C1 comma C2. Then finally end the module. Now this is the program. But when you execute this program, you won't get the proper output. You'll get the wrong output actually. The reason is what? The reason is the off underscore adder is not there in your system because already we are not written. The system will find is there any instance of underscore adder is there or not. So further what you need to do, you need to write a separate program, that is we can call this component program you have to write. That is we can call this the subprogram. The subprogram of off adder you have to write. So I will write as the subprogram module HALF underscore ADDR off adder. Then our inputs and outputs. Off adder input and output is like A comma B comma sum comma carry. Okay, next input A comma B, then output is S comma C, then off adder only. So XR will be there, XR X1, because off adder the sum expression is what? A XR B. So I can say XR output comma input. Output is what? XR output is sum. XR output is sum. Then inputs are A comma B. Then OR gate OR1. So OR gate is for your carry expression. So OR gate is for your carry expression in the sense. What is that output? Output is C. C comma A comma B. Enter. Then you close with end module. Now when you execute the program, whether you'll get a proper output, still you won't get the proper output. The reason is you have to be very careful here. You think of, see here I used, what is the name I used here? You see this name off underscore adder, correct? H is caps is there here actually. So here see H is small is there. So both should be same. That is very important. See, if I am doing like this, the system will search where this name like this. Where this off adder. So the system will search if both are same name, then only the system will can understand yes there is a off adder program, then I can execute. But there is one more problem also is there. You see here what is the order of the inputs and the outputs here. Order of the inputs and outputs. You see the S1 C1 is output, but AB is input. Now let me take simple example here. S1 C1 A B. Now you see of this off adder, what is this order? A B S C. What it will do in the sense, it will map the corresponding order. This position will be mapped with this position. This will be mapped with this position. This is mapped with this position. Now as of this, the S1 is output. Correct? But this here the A is input. The output and the input will not be mapped. So what I should do? So here we followed output comma input. So better even here also should be the same. So what I should do? So let me cut this. Let me write instead of that. How should write that? Instead of that I should write as S comma C comma A comma B. So you need to write like this. Then only this will be correct. So if you write like this, then this will become as wrong. Very important, the mapping is very important. So that is why instead of getting more confusion, what you do when you are writing the main program also, that is subprogram, when you write, what you do, you follow here output comma input when you write the subprogram. Or here you need to write A comma B comma S1 comma S1. Even you can write here also. That is not the issue. But you cannot write for this input comma output. Why? Because this is a primitive. but the half adder is not a primitive actually. Let's go for the next example. The same what we studied in the previous, like a 4-bit adder. Let us consider the 4-bit adder. Write the Verilog code for 4-bit adder using gate level model. Yes. Now let us write the program. Now what I will do, let me use a vector type here. Very easy. Okay. First, we start with the module. It's a ripple carry adder or parallel adder. Which are the inputs? A is the input, B is the input, then Cin is the input, then sum, that is yes, then C out. C out. Okay. Semicolon. Output C out also is there. How it will be in the sense, in simple, I can extend this diagram still actually. Example. Okay. So see, this will be your one block. So this is the block actually, you see. So here I will have C out. Yes. Input C in, A, B, S and C out. That is what I written here. Next, input. How many bit? It is a 4-bit. So what I should do? 3:0. It is A, comma B. Next, output. Not output. One more input also is this, right? Input. What is input? Is C in is there. C in. Then output. Yes, that is how many? Even that also 4-bit only. So yes. Next output. C out. Okay, now we'll see wire. How many wires are there? 0, 1, 2, 3. So what I will do? Let me take 3:0 wire. C. Now let us go for instantiate. Instantiate full adder. Yes. Now first, what I will do? Full underscore add or full adder. I will write as FA1. You see, let me take in this way. This is your FA1. This is FA2. This is FA3. You have to make it label better. This is FA4. FA1. Now you see only the full adder FA1. What is the input? What is the output? The inputs are A of 0, yes, comma B of 0, then comma C in. Next, S of, that is output. Inputs are over. Now output S of 0, then is C of 0. See? I hope you might have got it. Full adder FA0. You see only this one full adder. This full adder only you see. The inputs are A0. That is how I can't write A0 because the A is declared as a vector. You see here, very, very important. Vector inputs. If I want to vector inputs, when I declare as vector inputs. So here I declared as inputs are vector type as a 4-bit, but here the one full adder will access only single bit A0, B0, that is A of 0 and B of 0 because it is a 1-bit adder. The full adder has only 1 bit. Now A0, B of 0, C in, then S0, C of 0. Now let me go for the second. Yes. Now the second you see FA2, it is FA2, right? In second, you see what is that? A1, B1. Okay, A1, B1, A1, Next is B1, okay, A1, B1, A of 1, B of 1. What is input is here? It is C0. It is not C in, it's supposed to be C of 0. Okay, next is S1, next is C1. Okay. I hope you might understand this. Now we'll see this next third full adder. See the third full adder? What is the third full adder? It's supposed to be A2 actually then. This will be A2. This is A2, this is B2, because A of 2, B of 2, then one more input is C1, the previous carry. So C of 1, then sum will be S of 2, then carry here will be C of 3, not C of 3, C of 2, because see, it is C2. Next is what? FA1, FA2, it's supposed to be FA3, this one. This one supposed to be FA3, then this should be FA4. Now what is this? This will be A of 4, not A of 4, A of 3. Then this will be B of 3. Then here it will be C of 2, because see, C of 2 will be input. Then sum is S3. Then here what is that? C3. So C3, this is C3. Is there any more? Still, which variable is left out here? You see, the C out is left out, correct? So how can I write that one? Simple. How you can write in the sense? That is the thing I said. I hope you remember mixed model. Now I am going to incorporate the data flow model even here also. Just like I will write, assign C out is equal to C of 3. Yes, as soon as I get the C of 3 value, the C of 3 will be assigned to C out, where the C out is nothing but your output. Then finally, I can go as end the module. So when I execute this program, you won't get the output because of the full underscore adder is not a instantiation. It's not a full instantiation. Now what you can do, you can see this full adder program, where the full adder is see here. Already we written full adder. So this full adder will be called from here A comma B comma C. So automatically you can see whatever the name is given here, very important. The same name should be used here, the module name. That is very, very important. This is very, very important here. Okay. So then only the system can able to search. What the system will do in the sense, if you write any instantiation here, throughout the system, it will search, is there any name of with the full underscore adder with a module name, it will check. Once it is there in the sense, then the corresponding input and output parameter will be mapped. Mapped in the sense, it will check whether it is mapping input to input, output to output. That is the mapping you have to do. You cannot able to map input to output or the output to the input. It is not at all possible. That is the reason. So orders should be same. So be careful while writing the sub program. So now what you do, if this program is not available here in the sense, then you must to write the full adder. So that it's the full adder. When you write the full adder, it is not mandatory. You have to write the full adder in gate level model only. Even you can write the full adder in the data flow model also. The subprogram can be any model. It will work. So if you write in data flow model, within a simple, easily you can write. See example, I'll say I will write here module full adder, right? So full underscore adder. Then I'll say here A comma B comma C in comma sum comma carry. Then semicolon. Then inputs A, B, C in, then output S comma C. Now here I will write like this: assign S is equal to A XOR B XOR C in. Next assign carry is equal to A and B are with B and C in, then R with C in and with A. Then put the semicolon, then you can close it. See, we can write the subprogram as like this. So if you write like this in the sense, then it will be very simple. No need to write like that. This is subprogram. See here how it is. This only, this full adder, this full adder, this full adder should be same. Then you will execute. Then order is very important. See this order, input comma output. Even here also input comma output. That is very important here. Don't by mistake also don't write output comma input here. Then you won't get the proper output. So while coming in the next class, requesting it to all the students, kindly rename it with your USN number, or if you are having your name with the bracket, I need the USN number. Yes, there is a query in carry adder. Why we assign input output? Why not output input? In carry in adder. I think you are asking for asking here. I think you are asking here. If you are using the primitives, then you must follow the syntax. That is output comma input. This is a primitive. R is a inbuilt gate which is available in the Verilog actually. So you must follow output comma input only. But when I go in here, this block level, this is the block level actually. At that time, I no need to follow output comma input. Even you can write input comma output also. That is the reason here we written as output comma input. So here you can write anyway. But the very important thing is you need to keep the order remain same. Which is the order you followed here? The same order you must follow here also. That is the simple. Here you see we use primitives. These are all primitives. Very important. This is primitives. This is primitives, which is I'm shading with the red color now. These are all primitives actually, which is written in black color. These are identifiers actually. It is not a primitive. It is not available in the Verilog actually. We need to write separately. Is it clear? So is there any more doubt? Okay, I hope. Okay, I hope so. I think everyone understood the concept of this. So in the next class, what we will do, we'll go for the next model, that is behavior model. We'll see. So in that, it is most of them is equivalent to C program. So before that, little bit C you see and come, then it will be more easy for you. Even no problem. So we can try out in the class itself. So this is all about today's class. Thank you.